Nowadays, users are offered a number of services and applications that may potentially put their privacy at risk by handling their data in ways users may disagree with. Currently, it is difficult for a user to understand the privacy implications of using a mobile service or application. Privacy policies are often not easy to read, quite verbose, and commonly not presented upfront to the user. This issue is going to be even more pressing within 5G networks, where a single service may be the result of a compositions of different layers managed by different parties with different views on privacy. The core support for software-defined networking and network functions virtualization in 5G networks raises the expectation of new virtual mobile network operators being able to easily enter the market and bring innovative new business models. Users, however, need to be able to make an informed choice about how service providers handle their privacy and must be supported in the use of services. Moreover, different users may have different views on privacy and may consider as concerning or not different actions performed by the service. It is therefore important to tailor the reasoning backing up the privacy policy analysis to the personal view of each user. The privacy policy analysis enabler allows to do just that by semantically encoding privacy policies and using the user privacy preference to match and score available services. To showcase such capabilities, a scenario within the automotive domain has been devised, where different fictitious telematics providers offer similar services but with different policies regarding where the data is stored and how securely the data is collected and stored. To users, Bob and Alice want to purchase a car which offers different added value services that make use of vehicle connections to enable the user to have a better security via car accident detection and automatic connection to police and motoring associations. Bob is very concerned about secure storage and encryption, trusting technologies to protect his privacy. A privacy manager previously registered to the enabler uploads the file encoding the 4 policies to the enabler. The policies can be inspected to see the type of actions that are implied by the service. And we can see that the 4 policies mix the EU, non-EU storage and the encryption and unencryption. Bob logs in the enabler and specifies the privacy preferences which suits him best. In this case, Bob defines as not very concerning all the actions that are actually provide encryption of storage and transmission, but not really concerned about where the data is stored. Bob also specifies as very concerning all actions that imply non-encrypted transmission and storage of information. Once the preferences are submitted, Bob's search can return the services that best suit his preferences. We can see that his view on privacy can actually be tailored by more lenient or more strict. And we can see that higher score are granted for secure services regardless of where the data is stored. So EU secure and non-EU secure are the services which store the data outside or inside EU, but with encryption. And specifically, they use encryption when transmitting the user identity. On the other hand, Alice is very concerned about where the data is stored, trusting data protection laws in EU best to represent her rights to privacy. So when Alice logs in the system, the preference she specifies sets as not very concerning all the storage of data in EU, whereas is not very concerned about encryption of the data itself. So when Ellie submits her preferences, she can see that the services which are preferred by the scoring mechanism are actually the ones that store data within the EU regardless of encryption.